forget. And right. Okay, yeah, so we will get started with the material for today in just a moment. I will have gone over a majority of the homework that's due on Monday by the end of class today. But if you would like to go and talk to me if something is not working right for you on this Friday, of course, we'll do the regular optional homework sessions. So you can do that. Oh yeah, the exams are coming back. I've got, got some of them done, but haven't sent any back yet, but those will come back here in the next day or so. Okay, so give it just about a minute or so more and we will go ahead and begin. Right. Okay. So yeah, we're going to do some more t-tests again today. So t-tests are a test for differences in averages or means between two groups. In chapter 11, in my version of this SPSS book, it goes through and gives you step-by-step instructions on how to do t-tests and the interpretations of the output. And so that is something that you can always go through and look through this and see what's going on in the chapter, in addition to what I'm talking about here in these videos. So there is that as well. Okay, so yeah, so t-tests, we're testing for differences in averages or means between two groups. So what I'd like to do today is start with the homework. Somebody else here? And see if my screen is showing. Okay. Just give me a moment. Let me get this up. Okay. Sorry. Okay. Right. So here are a series of t-test examples. And so a t-test, again, is looking at average differences in some dependent variable based on your membership in some group. And so we'll take a look at this this one here with the grouping variable. We've used both of these before. Ever smoked a cigarette? So one group has and other group has not. And they're self-reported general health. Okay, and so we want to take a look at average differences in general health between those who have and those who have not smoked a cigarette. So that's our general task here with that. And so let's go ahead and do that by going to SPSS and taking a look at, we've already taken a look at the smoke to cigarette question, the general health question, so we don't need to go back and look at them in variable view again. Let's go over to data view. Can people still see my screen? See, I'm circling my cursor around. Okay, good. So we want to go up to analyze. And to do independent samples t-test, we go down to where it says compare means, because that's what we're doing. There's several entries here though, so we want to go down to the third one down where it says independent samples t-test. Okay, and I'm just going to reset this for the time being. And I want to put in as the grouping variable whether or not you've smoked a cigarette. And so I'm sorting alphabetically my variable names, H1TO1, okay, and so this is coded, let me make sure, this is coded 01, pretty sure it is. Oops, what happened there? Okay. Yeah, so what I'm doing here is making sure that this is coded 01. Yeah, it is. Okay. And so what we want to do is when we're doing our independent samples t-test, oops, H1TO1. So we want to define this as comparing group coded as 0 to group coded as 1, because these are the non-smokers and the smokers coded as 0, 1 respectively. Okay, and then we want to put in general health, and so that's H1GH1. I think, pretty sure, H1GH1. Yeah. Now, if you recall, this is coded so that the higher the score means worse self-reported health. So just keep that in mind. All right, so grouping variable is considered the independent variable in this, that you're belonging to one group or the other is thought to a causal impact on the average level of self-reported health. It's supposed to make it different from the overall average, depending if you smoke or if you do not smoke. Okay, so that's what we're testing for, that, if that has that effect. Okay. So let me scroll down here, and I think I have to share my screen with you all again, because I think that probably, okay. So I'm down here, group statistics. Can everybody see where I'm circling around the bottom of my screen? Okay, I'm getting shaking heads, nodding yes. Okay, so that's good. All right, so these are the people, no, they've never smoked a cigarette, 2,863. The people who said yes, they've smoked cigarettes before, 3,586. Here is their self-reported average, the self-reported average for the non-smokers and the smokers. Okay, so if you recall, the higher the score on the self-reported general health scale means the worse self-reported health you were reporting. Okay, so intuitively it makes sense then that the self-reported smokers are self-reporting worse average health compared to the non-smokers, right? Because they have the slightly higher score. The question is that difference that we've observed there in the sample big enough to suggest that there's a significant difference in the population? That's what we're testing for. Okay, and so when we do this test, we come down then to this table down here where it said independent samples t-test. All right, I'm going to first talk to you about what this F stat is, because we have not done that before. That stat, that first stat that is shown there, is a test of whether or not we can assume that there are equal variances in general health for the non-smoking group and the smoking group. So variance is just a square of the standard deviation for these groups, and so it's assuming that the variances in the populations are either equal or they're not assumed to be equal in the population. So the test, the null hypothesis for this F-test, for the F-test, is that the variances are assumed to be equal. So if we get a significant F-test, that means that the variances are not assumed to be equal, which is important in some cases because that means we have to look at the second t-test down. Okay, and so in this case, this F-test is showing that it's statistically significant. Again, the cutoff point for the level of statistical significance when we say it's significant is 0.05. It's 0.05 or smaller than we say it's statistically significant. So this F-test is saying that we can't assume that the variances are equal in the population for self-reported health between the smokers and non-smokers. They're different, and so our calculation has to be different. And so that's a significant test. And so that means that we have to go with the second t-test down is the one that we look at when the F-test, Levine's test for equality of variances, it proves to be significant. We look at this second one down because that's the one that says, okay, we reject the null hypothesis that variances are assumed to be equal in the population. So we go with this slightly different way in calculating T. Now, if the differences in averages are big, then it really doesn't matter what T you look at. But we'll see maybe in an example we see today where the averages are close enough for the T's, which T you look at really does matter. But anyway, for this one, it didn't really matter. But in any case, you would be using this because this is significant. You would be using the second t-test down to judge whether or not there are significant differences in health between smokers and non-smokers. All right. Over here, you see another column that we talked about previously. This says significant two-tailed test. So this is a two-tailed test because it's two-tailed in assuming that we don't know what kind of effect smoking will have on general health, if it's going to push it above or below the population average. And so the two-tailed test is calculated differently than the one-tailed test, where you have you can say confidently that we assume that this is going to be the directional effect on the dependent variable. Usually you use two-tailed tests because they're harder to show statistical significance. It's a more conservative test, they say. All right, so again here, this significance test, or what's called the p-value, the probability of committing a type 1 error, okay, it's called the p-value, is approximately 0. And so that's good in terms of showing that something is statistically significant because we don't want it to be any higher than 0.05. Okay, so we can conclude then that the t-test of negative 10.396 is statistically significant. The p value is 0.000, which means there are significant differences in averages between smokers and non-smokers, significant differences in average or in general health between smokers and non-smokers. So that's what statistical significance means for a t-test, that there are significant differences, in this case in general health, and average general health between smokers and non-smokers. All right. So are there any questions about any of that? Some of the stats that I just pointed out here, what we're looking at here are the averages for the non-smokers. Here's the average for the smokers. Here's the F-test. Usually it doesn't matter if it's what the F-test says because the T's are going to be similar anyway. But in this case, because the F-test is significant, we look at the second T down, and then we look over it here at this significance test, this two-tailed test, and we note that the probability of committing a type 1 error is less than 0.05. So the p value is 0.000. It's less than p is less than 0.05 is how you would write it, and that means that there's a statistically significant difference between smokers and non-smokers and their self-reported general health. All right. So questions about that, about any of that, where I'm getting those numbers from, the interpretation of that, because we'll do this, okay, a couple more times. All right, so let's take a look at another one. Let's look at Oh. Okay, so this one using the same grouping variable, ever smoked a cigarette, examine an independent samples t-test with ever smoked a cigarette as the grouping variable, and H1RE3, past year, attend religious services, the dependent variable. So we're testing for average differences in religious attendance between smokers and non-smokers. All right, so we may have some of our assumptions about which way this is going to go, but this is why we do statistics, to figure out for sure which way this is going to go. So let's go back to analyze. Oops, let me look real quick here at H1RE3. Okay. Okay, so you should be able to see my screen now. I'm going to analyze and going to do the same thing, put this through the t-test. Compare means, independent samples, t-test. Okay, so we can keep this grouping variable the same because it's the smoking variable that we want as the independent or the grouping variable. And it was H1RE3. Actually, before we do that, let's look at H1RE3 over here to see how it's coded before I get ahead of myself. H1RE3, because this is very important for the interpretation of how you interpret the output. Okay, and so this was H1RE3, past year attend religious services, and so this is how this is coded. So it's coded once is once a week or more, to 4 is never. So the higher the score, the less you attended religious services. Okay, so that's a good thing that we looked that up, because we could get very confused in our interpretation of our t-test if we didn't realize that the higher the score means less religious service. Okay, so people who are going pretty much on a regular basis to people who never go. That's the range of the religious attendance item. All right, so let's then go back to our compare means, independent samples t-test. Okay, and put this one back over there, and we'll go for H1RE3. All right, and we'll go ahead and look at the results for this. Okay, so down here we have past year attending religious service. Remember, the higher score means the less you've attended. So here is the score for the mean score for the non-smokers.
You can't see it.
Oh, we can. Oh,
yeah, sorry.
Thank you. Yeah, thanks for reminding me. Okay, can you see it now? Can you see t-test, group statistics? Yeah, okay, great. So here we've got the group statistics box. Here is the no for not smoking. Here's the yes for the smoking. The average score for past year attended for the non-smokers, and the average score for the smokers. And so if you recall, the higher the score means that less religious attendance, and so the smokers are reporting less religious attendance on average than the non-smokers. Okay, so there's definitely a difference here, but we can't just eyeball it. We need to look at the tests down here. So we have a significant F test. So that means that we want to look at the second t-test down. So the t-test is a negative 11.565. And it's negative, folks, just because in the equation, if you look back at the slides on the equation for the t-test, what we'll be doing is subtracting 2.12 from a 1.80. So that's why the t-test is coming out negative. But t's like z's can be negative and positive. So anyway, we're looking at that t-test. And is that a statistically significant t-test? Oh, yeah. So the significance level is 0.000, or the p-value is 0.000, and so that's less than 0.05, and so we can conclude that there is significant differences in religious attendance between smokers and non-smokers, that non-smokers attend religious services more often on average than smokers do. Okay, so there's that one. Okay, so any questions yet on what we're doing here, what we're looking at to interpret these results? We're looking at, here's the actual means. Here's a number of people into these groups. There's the F test. There's the T test here, and then there is the significance level, or is otherwise known as the p-value. So the p-value here is telling us that it's essentially zero. The chance of committing a type 1 error is essentially zero, and that means, therefore, that there's average differences between smokers and non-smokers in religious attendance is statistically significant.
I have a quick question.
Yeah.
So, does it matter which t-test we look at yet, or it doesn't matter?
It has not mattered yet, because in both cases you have significant t-tests. So it doesn't matter. It would matter if this would be well, it's not so much if this is significant or not. If the t-tests are different, and if this is so different that this is now not significant, but this one is, then it would be consequential. But right now it's not consequential. But just keep in mind, if this is non-significant, then you would look at that first t-test. That's the one you would use. That's the one that would be the most appropriate. Yeah.
Thank you.
You only look at the second one if this F over here is significant itself. And if it's not significant, then you look at the first t-test over. Again, that deals with assuming that the variances are equal or not equal in the population, and that's an assumption you have to make. You can't really observe it directly. We're doing it through sampling, and so there's just an equation that's different for one assumption versus the other. Okay, let me go back to the next one. Okay, so for this one, I want you to, we're going to go back to doing something that we did already once in this class. We're going to do more of is computing variables out of existing variables. So for this one, I'm asking you to compute the variable delinquency by summing the variables H1DS1 through H1DS15, and then examine the independent samples t-test with the smoking variable again as the grouping variable, and delinquency this time as the dependent variable. So again, you may have your assumptions about how this is going to turn out, but anyway, we'll go ahead and do this. All right, so I'm going to show you how you can quickly make this delinquency variable. So let me go find the string of variables H1 DS1. Okay. Now, can you all see that I'm on the variable view screen? Okay, right. Okay, so this is a list of items. H1 DS1 through 15 is a list of items that talks about juvenile delinquency crime, and so this is the first item is 12. How often in the past 12 months have you painted or used graffiti? You've done graffiti. And this is how all of these things are scored. 0 is never, and 3 is 5 or more times. Okay, and so all of them 1 through 15 are scored like that. Here's another one: burglarizing a building. How often have you done that in the past 12 months? So it's all of these questions about all these different crime items that are in the past 12 months. So that's graffiti, damaged property, shoplift, serious physical fighting, seriously injuring somebody, running away from home, stealing a car, stealing something worth more than $50, burglarizing a building, using or threatening a weapon, selling drugs, stealing something worth less than $50, taking part in a group fight, loud and rowdy in a public place, so disorderly conduct. And so you've got those 15 items. An easy way to go about just computing these rather than punching in one by one, you can just highlight, should work, highlight, copy, go into transform, and then we want to go into where it says compute variable. I'm going to go ahead and reset this. I already did it once, but I'll make it again. So we want to name our variable where it says target variable. We'll name it delinquency. Okay, and then we can just go, we can right click and paste and get all of those in there. And then what we have to do is we have to put parentheses around it and around the first variable, and then we'll put a comma after each one of these before the very last one, until the second to last one. This is just a little bit of a shortcut. Okay, so I've got parentheses and I've got a comma after every one except the last one, and I'm going to put then I'm just going to type sum in front of it. You can find this function over here, but this is just a shortcut way rather than going through and finding each one of these variables and putting a plus sign after each one of those. You can just put them cut and paste and put them right into there, and then put parentheses around and then put a comma after each one except the last one, then put sum in front, and you can make a variable like that. All right, so this should work. Yeah. Okay. Yeah, I'm going to change existing variable because I made it already once because I was messing with this before class. Okay, and so let me stop sharing for a second and go back to this. Okay, so this is just showing your syntax. So it's compute delinquency, and this is the sum of all these variables. All right, so let me go to analyze frequencies, and I'm going to go ahead and run a frequency table on this delinquency variable. Okay, and so here's my delinquency variable. It ranges from 0 to 45, and so here are the non-delinquent kids that are fairly well behaved, and here are the really badly behaved kids down here. Only 42 missing from this measure, so that's pretty good. All right, so we want to know if there's a difference in self-reported delinquency on average between smokers and non-smokers. All right, so in order to do that, let's go up to where it says analyze, compare means, independent samples t-test. Okay, so we can get rid of this religious services variable, and we're leaving in the ever smoked grouping variable down there as the independent variable. And then going down to, let me sort by file order. That way it'll show up last. The last variable I made will show up last in order, and put delinquency over there. And so we'll be testing to see if there is a difference in delinquency, average self-reported delinquency between smokers and non-smokers. And we hit OK. Okay, and so we've got here is delinquency for non-smokers. Here is average delinquency for smokers, and so a notable difference, about a 3-point difference here, 2.39 versus a 5.44 for the smokers. All right, and we look down here. We look at our F test for assumed variances being equal. We notice it's significant, so we use the second t-test down. It's negative 26.565. And so we look to see if that is a significant t-test, and you probably could have guessed because of the size of the t-test, it is definitely statistically significant because the two-tailed significance for the t-test is a p-value of 0.000. So that's saying that's basically there's a 0 probability that these differences in averages were found merely by chance. In another sample, you're going to find that they really are the same. It is saying, indeed, that there is a statistically significant difference in average self-reported delinquency between smokers and non-smokers, and the smokers are reporting more delinquency on average than the non-smokers. Okay, so that is yet another example of a t-test. That's when we made a variable first, and then and then use the smoking grouping variable as our independent variable. And so in your homework, I'm asking you to use that delinquency variable in your examples that you're going to put in for your homework. And so that you saw how I did that. You can cut and paste, or you can just do variable plus variable plus variable plus variable when you're making that delinquency variable. But anyway, that's that. All right. Okay. So let me stop sharing and take a look at this next one. Okay, so this one is a little different because we're going to use a variable that has more than 2 levels to it, marital status, as the grouping variable. But in t-test, you have to specify that you're only comparing 2 groups because that's the limitation of the t-test. It can only compare, let's say, married and never married people. So we're going to be looking at the marital status of the parents of these kids, because there's also data in here on the parents. The parents filled out a survey too, and so they reported on their marital status. And then we're going to compare that to the kids' self-reported delinquency. And we're going to compare married to never married. And we'll see if there are differences in self-reported delinquency between kids from families that are married versus families that are never married. Okay, so in order to do that, let's first take a look at the marital status variable. So that is PA10. And so, yeah, for future reference, all the variables that start with PA were asked of the parents. So this data set contains data asked of kids that were about freshman, sophomore in high school, some a little bit older, and then data from their parents. Oftentimes it was mom completing it. But here is the variable for marital status, and this is the way it was coded. So 1 is single or never married, 2 is married, 3 is widowed, 4 is divorced, 5 is separated, and 6 is responded, refused to answer. So it's a missing case. All right, so we want to compare category 1 to category 2 in our grouping variable, because we want to compare the single or never married to the married. That's what we want to do here. We want to do it for delinquency. Okay, so it's PA10. So we want to go up to where it says analyze and go to where it says compare means and independent samples, t-test. And we can keep delinquency there, but we want to change this grouping variable out. And we want to go down to PA10. Okay. And when we define groups, we want to compare the never marrieds to the marrieds. So that's comparing group 1 to group 2. All right. You could compare any one of those groups you would want to any other one of those groups that you would want to. I'm just comparing the never married to the marrieds. Usually you find some of the biggest differences in various outcomes when you compare people who've never been married to the marrieds as opposed to divorced or some other category. So I'm just going to use these 2 groups. So we're comparing the marrieds to the never marrieds to the married, and we're looking at self-reported delinquency of their kids. All right, we hit OK. All right, and so we come down here and we note here's the delinquency, self-reported delinquencies for the never marrieds. And that is 4.56. And then for the marrieds, it is lower. It's what's that? Oh, I'm sorry.
I think you can see it.
Yeah. Sorry about that. Thanks for reminding me. Okay, so we are down here, and here is our t-test for delinquency, average delinquency difference between the never married and the marrieds. So over here we have delinquency for the single or never married group, and this is the average is 4.56. And here it is for the marrieds, kids from married homes. That is, the delinquency score is lower. It's 3.77. All right, so Is that difference statistically significant? Well, we go down here and look at our F-test first. We notice that the F-test is statistically significant. That is lower than that's 0.05 or lower. And so that means that we look at the second t-test down here, which it is a little bit smaller than the t-test up here, but it doesn't matter because it still meets the threshold for statistical significance, because the p-value here is 0.008, which is smaller than 0.05. So you can conclude that kids from single or never married homes are reporting on average more delinquency than the kids from married homes. There is a statistically significant difference in those averages. Okay. Right, so I think that is about it. I don't know if there was one other thing on here. Let me take a look. This is all I would want to do today, is just do these t-tests. And then the last one, number 5, is asking you to conduct your own independent samples t-test. Use delinquency as the dependent variable in both of your examples. Use 2 different independent grouping variables from those shown above in your examples. Post your SPSS output directly onto this homework, and also answer questions A, B, C, D, and E for both of your examples. And so you're just repeating the steps that we did for all of these above, but for your own examples, for your own t-tests. And so we just fill out the above and then do these for your homework on Monday. And that will be it. And so that's it for today. If you have questions about what we did today, we still have some time left. So by all means, you can stick around. But if you do not have questions and you're pretty confident that you know how to do these t-tests, then you are welcome to go. Or if you want to come on Friday and ask me, you can do that as well. It's not due till Monday. Okay. So if you are all good, then unless you have questions, you are free to go. I will see you maybe on Friday, but that's all then for today. Bye-bye.
I have a question real quick.
Yes.
The one assignment, it's like a link, it's the T-chart or T-tables and something like that. Nothing's due for that, just the assignment due on the 1st, right?
Right, yeah, that was
Okay.
just something that we did in class.
Yeah, I was just making sure nothing was due for that.
No, nothing's due for that. That was just examples
Okay.
we were doing in class. Yeah, so.
Okay, thank you.
You're welcome.